Out in this chapter is all things absolute value. So, equations and inequalities, we are covering them all at once. You guys have seen these before, so hopefully it's just a matter of reviewing some things. But if there's something that you need more examples on, just tell me and I'm happy to do more. And first, do you guys know what absolute value is? What does it look like? 2 bars. What does it do? Okay. It measures how far something is from 0, so it's always positive, right? If you put in a positive number, it doesn't change it. If you put in a negative number, then it becomes the opposite. So, for absolute value equations, if I say the absolute value of A equals B, to solve that, you make 2 separate equations because it could be that the thing you put in was positive or it could be a negative. So for example, if I said the absolute value of x equals 3, then that means x could be 3 or x could be negative 3. So if we were solving equations, we just set up 2 separate equations, set it equal to the positive and the negative, and solve them. If the absolute value of A is greater than B, do you guys remember how we solved those? Let's think through one then. If I said the absolute value of x was greater than 2, think about it on a number line, what this tells me. It says that x has to be more than 2 away from 0. Absolute value is how far you are from 0. So if I'm at 2, that's exactly 2 away. If I want to be more than that, I would have to be over here or over here. Right? Those would be the situations where it would be further than 2 away from 0. So if it's a great or than, remember the ands and the ors, so then your 2 inequalities, you have A is greater than B, or A is less than the opposite of B. So when you do the less than and the opposite, that was our great or than. If the absolute value of A is less than B, do you guys remember what the less thans were? Those were our ands. Do you guys remember, did you write them as 2 separate inequalities or a compound inequality last year? I don't really care. I usually do a compound one, but if that's not the way you typically did it last year, I'm happy to rewrite it. So what this means, if I said the absolute value of x is less than 1, that means your distance from 0 has to be smaller than 1. So you would have to be in this window right here. So those were the less than is an and. So great or is an or, less than, that's your and I usually just do one big compound inequality. You're welcome to write 2 separate inequalities and put an and in between, and then your final answer is just the overlap. That's just a personal preference. So let's look at some problems. All right, if I ask you, do you always sneeze and freeze?
I don't know. It's allergies.
All right, first thing on any of these, the absolute value has to be isolated. Okay, if you have something else added or subtracted outside the absolute value, we have to move it to the other side. This one it is isolated, so I'm ready to just make my two equations. So if it's an equation, you just do two separate problems. 9 minus 4x equals 7. 9 minus 4x equals negative 7. You just make the 7 positive and negative. Now we solve each. Negative 4x equals negative 2. We get 1/2. This one, negative 4x equals negative 16 divided by 4. Negative 4 and we get 4. I don't care if you write it like that. Solution set is great, but if you just put x equals, I'm fine with that as well. Can you check these? Yeah. I can definitely put these back in and see that if I put in 1/2, I get absolute value 7, which is 7. If I put in a 4, the absolute value negative 7 is 7. So we can always check there. Okay, so this one looks different because I have absolute values on both sides. What do you think I need to do? There's still really only two options. Either these numbers are the same or they're opposites. For instance, they could both be a positive 2, or one could be positive 2 and one could be negative 2, right? So for that, our two options, 3x plus 2 could equal x minus 5. Or 3x plus 2 could be the opposite of x minus 5. Okay, notice I put my negative out in front. You just have to make one of the two sides negative. Doesn't matter which. But I wrote it out there so we could see we have to distribute that negative to both terms. So then if we solve, we get 2x equals negative 7. That's negative 7 out. Do you guys remember sometimes you solved absolute value equations and you got answers that didn't work? Do you remember what would make an answer not work? It was when your variable was outside the absolute values. So both of my x's were inside an absolute value. We can certainly plug them in and check, grab a calculator if you need to. If you ever have a variable outside your absolute value, that's when you really need to be cautious and just double check your answers and make sure they work out. Any questions on those two? Let's look at this one. So when I see less than Is that and or? And. You can do it two different ways. Some people like to write two separate inequalities with an and in the middle, which is fine. When you do this one, you have to flip it and make it a negative. The only problem is then some people get to the end and they don't know how to interpret their answer on this. So if you want to do it that way, that is totally okay. What I usually do, if it's an and, then I know it's between two numbers. So this is my -7, I'm going to put, or that's my 7, I'm going to put -7 on the other side and write it as a compound inequality. And you just put that expression in between the positive and the negative. Do you guys have a preference on which way I do all that? Okay. Then I will probably do on all the ands, just make a compound inequality. So now we know how to solve those. We subtract 1 from everything. So -8 less than 2x less than 6. Divide everything by 2, so -4 less than x is less than 3. How do we need to write that? In interval. So it's saying it's everything between -4 and 3. Those ands, you should always get a single interval at the end, just in between the two numbers. If I said the absolute value of 3x plus 4 is greater than 5. Let's do greater than or equal to. Okay, when I look at this, greater than or equal to, what does that tell me? Or. So for ors, I do two separate ones. The first one, all you do is drop your absolute value. So 3x plus 4 greater than or equal to 5. Or, for the second one, you flip the inequality and make it a negative. Make sure you flip that inequality. Just like if you multiply by -1, it flips your inequality. So if we solve each of these, 3x is greater than or equal to 1, so x is greater than or equal to 1/3. This one, 3x is less than or equal to -9, so x is less than or equal to -3. How do I write the interval for these? Okay, the equal to means a bracket. If you need to, think about a number line. Greater than or equal to 1/3 would be a bracket at 1/3 going to the right. Less than or equal to -3 should be a bracket at -3 going to the left. So these are two separate pieces. Make sure you put the small to large. So -infinity to -3 with a bracket. Union. Bracket 1/3 to infinity. So when you have an or statement, we get two pieces at the end. When we have an and statement, we get one piece at the end. Questions about those two? What if I gave you this one? What do we have to do first? Add the 1. You have to have the absolute value by itself before you rewrite the problem without it. So the absolute value of 2 minus 7x is greater than 5. So now, and or? Right? Or is an or. So we do two pieces. First one, just drop the absolute value. Or, second one, flip the inequality, make it a negative. Solve these, so if I subtract by 2, what happens if I divide by -7? You can draw a number line if it helps you. I don't require it. Less than -3/7 is everything smaller, so to the left. Greater than 1 is everything bigger than 1, so to the right. So it was an or, we were expecting 2 pieces, and that's what we got. So -infinity to -3/7. 1, 2. You think you can try a couple? Alright, do those 2 problems so I can make sure we're okay. So first one, everyone remembered you have to subtract your 6 before you make your 2 separate ones. So the value of 5 minus 8x is less than 8. Less than is and, so we put it in between -8 and +8. So if we solve, subtract our 5. When you divide by -8, what happens? So how do I write my final interval? And then to write.
Sorry.
No, you're different question. So your interval, make sure you go small to large, is saying that x is bigger than the -3/8 and smaller than 13. On C, so if we add our 1, is this and or? And again, so we just put it in between the negative and the positive. Subtract 1. Divide by 3, so we get -4/3 less than x less than 2/3. So interval and should always have 1 piece at the end, or should have 2. Look like that. Any issues with those? Okay. I have one final slide I want to look at. These are just some special situations. What if I say the absolute value is equal to 0? We always set it equal to the positive and negative. Is there a positive and a -0? No. So we only have one equation to solve. So if it's equal to 0, you're only going to get one answer. So subtract my 28, divide by 7, and we just get -4. What if I said the absolute value of 6x minus 9 is greater than -2? What's different about this problem? It's greater than a negative. If you ever run into one of these situations where you have an absolute value on one side and a negative on the other, okay, it might be an inequality, it could be an equation. If it were an equation, can the absolute value of x equal a negative? No, so what would your answer be? No solution that we're equal to. Okay, here. Can an absolute value be bigger than a negative? Yes. When is it bigger than a negative? Always, right? Every number that you take the absolute value of, it'll either be 0 or a positive number, so it's always going to be bigger than -2. So what do you think my answer is? It's infinite solutions. We write that as negative infinity, positive infinity. If you catch it, you can just write your answer. If you don't, you can still solve it like we do typically. So you solve it as an or. The difference is when you get to the end, these are going to overlap. So if I think about a number line, greater than 7/6 would look like this, less than 11/6 would look like that. What got shaded? My whole number line. So that's why it's negative 8, positive 8. All right, what if I said an absolute value is less than a negative? No solution. An absolute value is a positive number. Can it be smaller than a negative? Never. So again, it's no solution. If you worked it out and solved it, less than is an and, you would get two pieces that never overlapped. So we would be able to tell there as well. All right, so if you catch those shortcuts, you can just write down the answer on it. You don't have to work them out. So I have some problems for you. This is due tomorrow. And you have time to work right now.